In this video, we are going to determine an unknown two-digit number by forming pair of linear equations in two variables using the conditions given in the question. The question here is the sum of the digits of a two-digit number is 9, and the second condition is 9 times this number is twice the number obtained by reversing the order of the digits. We need to find the number. Let's start our solution by assuming the number in tens place to be x and the digit in units or ones place to be y. So our number will be 10x plus y. The digit in tens place will be multiplied by 10. Let's take an example to understand this. If our two-digit number was 25, then 25 when written in expanded form should be expressed as 10 into 2 plus 5. The digit in tens place 2 should be multiplied by 10. The place value 10 2s are 20 plus 5 gives us 25. So number is 10x plus y. Now as per the first condition, the sum of the digits of a two-digit number is 9. So when we add x plus y here, the sum will be 9. For example, if 25 was our number, then on adding the digits 2 and 5, the sum would have been 7. Here on adding x plus y, the sum will be 9. That's as per the condition given in the question. So as per case 1, sum of the digits is 9. That means adding x plus y should give us 9. So this will be our equation 1. Now the second condition says 9 times this number as in 10x plus y, 9 times this number 10x plus y is twice the number obtained by reversing the order of the digits. Twice of the number which is obtained by reversing the order of digits. That means x and y will switch their places. The digits will reverse their places. So in place of x we'll write y, and in place of y we'll write x. 9 times this number, the given number, is twice the number obtained by reversing the digits. So this is as per the second condition. Now let's just simplify in order to get the second equation. 9 tens will be 90x, 9 into y is 9y, 2 tens are 20y plus 2 into x are 2x. Let's bring all the variables to one side. 90x minus 2x plus 9y minus 20y, and we don't have any constants, so equals to 0. 90 minus 2 will give us 88x plus minus minus. 20 here is the bigger number, so minus sign will retain. 20 minus 9 will be 11. Y equals to 0. 11 can be taken common, so on taking 11 common, 11 8s are 88. So 8x minus 11 has been taken common, so 8x minus y equals to 0. On taking 11 to the other side, we'll get 8x minus y equals to 0 by 11, or 8x minus y equals to 0. 0 by 11 or 0 by any number is always 0. So our two equations are x plus y equals to 9 and 8x minus y equals to 0. Now these two equations can be solved quite easily using any algebraic method. Let's apply elimination method. And since the coefficients of x are already the same, so we don't need to multiply with any constants. Solving equation 1 and 2. Equation 1 is x plus y equals to 9, and equation 2 is 8x minus y equals to 0. We want to cancel y and their signs are already opposite. That means we'll add the two equations. That means the sign of the lower equation won't get reversed. Plus y minus 1, they'll get cancelled. X plus 8x will give us 9x equals to 9 plus 0 will be 9. So x equals to 9 by 9. So we'll get the value of x as, so I've got x as 1. Now let's replace x as 1 in either equation 1 or equation 2 in order to get the value of y. Let's use equation 1. So let's put x equals to 1 in equation 1. Equation 1 is x plus y. So that means 1 plus y equals to 9. Y equals to 9 minus 1. So the value of y is 8. So we got the value of both x and y. Now our number was 10x plus y. So we'll conclude our answer. Hence, the required number equals to 10 in place of x1 plus in place of y 8. 10 ones are 10 plus 8. So 10 plus 8 will be 18. Now the next question. Here we have the sum of a 2-digit number and the number obtained by reversing the digits as 66. And this time around we have been given the difference of the digits. If the digits of the number differ by 2, we need to find the number. We also need to check how many such numbers are there. Last time around we were given the sum of the digits, and this time around the condition says the difference of the digits. So let's start our solution. So we have assumed the digit in tens place to be x and the digits in units place to be y. So the number will be 10x plus y. The digit in tens place will be multiplied by 10. Now as per the first condition, in case 1, sum of 2-digit number, that means 2-digit number is 10x plus y, sum, so that means we'll add, and the number obtained by reversing the digits. So on reversing the digits, the number will be 10y plus x. On adding the number and the number obtained by reversing the digits, the condition says we'll get 66. So this is as per case 1. Adding the number and the number obtained by reversing the digits, the sum will be 66. Let's bring the like terms together. 10x plus x, y plus 10y. This is not required, but still let's do it properly. 10x plus 1x will give us 11x. 1y plus 10y will give us 11y equals to 66. 11 can be taken common, so we'll get x plus y equals to 66. So on taking 11 to the other side, we'll get 66 by 11. 11 ones are 11, 11 six are 66. So x plus y equals to 6 will be our first equation. Now case 2 here will be slightly interesting, because unlike the last time where sum of digits was given, this time around we have been given the difference between the digits. And from our assumption, we cannot determine whether x is greater or y is greater. So we cannot say on subtracting which digit from the other digit we will get 2. So on case 2, we will have two different cases. Either x minus y will give us 2, or y minus x can also give us 2. We are not sure about any of the cases, so we need to consider both the cases. So we'll have 3 equations. Mind you, these 2 equations are from the same case, so we cannot solve these 2 equations. So now let's solve equation 1 and equation 2 first and check what will be the number. Solving equation 1 and equation 2. So on doing so, x plus y equals to 6 and x minus y equals to 2. Plus y minus y, they are already opposite, so we can add the 2 equations. Y will get cancelled. 1x plus 1x will give us 2x. 6 plus 2 will be 8. So x equals to 8 by 2. 2 4s are 8, so that means x will be 4. Let's put the value of x in equation 1 and get y as well. put x equals to 4 in equation 1, we'll get 4 plus y equals to 6. Y equals to 6 minus 4 will give us y equals to 2. So we got x as 4 and y as 2. So our number will be, hence the number will be 10 into, in place of x, 4 plus y 2. 10 4s are 40 plus 2, 42. But in case 2, we had two different cases, as we were undecided whether x was the greater number or y was the greater number. So from that particular case, we had got one more equation which said y minus x equals to 2, wherein we are assuming y to be the greater number. So this also needs to be considered. Now if y minus x equals to 2 instead of x minus y being 2, then the value of y will be 4 and the value of x will be 2. So in this case, hence the number will be 10 into, in place of x, 2 plus y is 4. 10 to the 20 plus 4, 24. So as per the question, we were asked how many such numbers are there, how many such possibilities are there. So we'll finally conclude. Therefore, there can be two such numbers and they are 42 and 24. So when the difference between the digits are given, there can be two possibilities, but still solution more or less is the same.